Let's understand perimeter and area in this video.
Have you ever measured a fence around a garden? Or wrapped a ribbon around a gift and wondered how much length you need? Perimeter is simply the total length around a shape. The distance you walk if you go all the way around and come back to the start. For a square with side A, the perimeter is 4 times A, written 4A.
For an equilateral triangle with side A, the perimeter is 3 times A, written 3A.
For a rectangle with length A and width B, the perimeter is 2 times the sum, written 2 times open bracket A plus B close bracket. A useful idea. For similar shapes, the ratio of perimeter to a characteristic length stays the same. For example, squares have ratio 4 by 1 and equilateral triangles have ratio 3 by 1. Now let us look at a circle. The perimeter of a circle is called the circumference. Ancient people found that circumference divided by diameter gives the same number for every circle. We call this number pi, written pi, about 3.14159. So circumference C equals pi times diameter d. That is, C equal to pi d. And since diameter is 2 times r, C equal to 2 pi r. A short history of pi. In Mesopotamia around 1900 BCE, they used pi about 3 and 1 by 8. That is 3.125. Archimedes in 250 BCE trapped pi between two many-sided polygons and got tight bounds for pi. Ptolemy around 150 CE used the fraction 377 by 120, about 3.14167. Zhu Chongzi around 480 CE gave the very good fraction 355 by 113, about 3.1415929. Aryabhatta used 62,832 by 20,000, which equals 3.1416, and called it an approximation. Brahmagupta sometimes used square root 10, about 3.1622 for simple work. Madhava around 1400 CE wrote an infinite series for pi over 4 equal to 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 and so on, and found many decimals. Then William Jones introduced the symbol pi, and Euler made it popular. Pi is irrational. That means it cannot be written exactly as a ratio of two whole numbers. So decimals go on and never repeat. Good practical approximations are 22 by 7 for rough work, 355 by 113 for high accuracy, or decimals like 3.14 or 3.1416. We celebrate Pi Day on March 14 because the date 3-14 matches 3.14, and Pi Approximation Day on 22nd July because of 22 by 7. A memory trick for digits is the sentence, "How I wish I could recollect pi," where the number of letters in words gives 314159 and so on. Next, arc length. A full circle has length 2 pi r. A semicircle has length pi r. And a quarter circle has length pi r by 2. For a general arc with central angle theta degrees, arc length L equals 2 pi r times theta degrees by 360 degrees. Here is a real example from athletics. A 400-meter track has two straight parts of 84.39 meters each, so straight total is 168.78 meters. The semicircular ends use radius 36.5 plus 0.30, which is 36.8 meters. So two semicircles give 2 pi times 36.8, which is about 231.22 meters. Adding gives lane 1 total 168.78 plus 231.22 equal to 400 meters. Lane 2 radius is 36.5 plus 1.22 plus 0.30 equal to 38.02 meters. So the extra distance in lane 2 is 2 pi times 1.22, which is about 7.66 meters. This is why starts are staggered on the curved track, to make each runner cover the same total distance. Now areas. A square with side A has area A squared, written A times A. And a rectangle with sides A and B has area A times B. A parallelogram has area base times height, written base B times height h. And you must know the height measured at right angles to the base. A triangle has area 1 by 2 times base times height. That means half of base times height. A median from the top vertex divides a triangle into two smaller triangles of equal area because they share the same height to the base split in two. Heron's formula finds the area when you only know all three sides A, B, C. First compute S equal to 1 by 2 times open bracket A plus B plus C close bracket. Then area equals square root of S times open bracket S minus A close bracket times open bracket S minus B close bracket times open bracket S minus C close bracket. For a 3, 4, 5 triangle, S is 6 and area is square root of 36, which is 6 square units. Here is the kite problem. A square has diagonals 44 centimeters. So half diagonal AO is 22. Using Pythagoras, AB equals 22 root 2 centimeters. Area of the square equals side squared equal to open bracket 22 root 2 close bracket squared, which equals 968 square centimeters. So each of the four triangles inside is 968 by 4 equals 242 square centimeters. To find the lower small triangle with sides 20, 20, 14, use Heron. S equals 27 and area comes to about 131.14 square centimeters. So area of red region equals 242, yellow equals 242 plus 242 equals 484, and green equals 242 plus 131.14, which is 373.14 square centimeters. There are two more useful area formulas using circles. Triangle area equals A times B times C divided by 4R, where R is circumradius. And area also equals R times open bracket A plus B plus C close bracket divided by 2, where R is in radius. Brahmagupta extends Heron for a cyclic quadrilateral with sides A, B, C, D. Let S equal 1 by 2 times open bracket A plus B plus C plus D close bracket. Then area equals square root of open bracket S minus A close bracket open bracket S minus B close bracket open bracket S minus C close bracket open bracket S minus D close bracket. Bodhayana showed a geometric way to make a square equal to a rectangle using steps that use midpoints, arcs and parallels. Based on the identity open bracket A plus B by 2 close bracket squared minus open bracket A minus B by 2 close bracket squared equals A times B. Area of a circle is pi times r squared because Archimedes showed area equals 1 by 2 times circumference times r, which simplifies to pi r squared. A sector with angle theta degrees has area pi r squared times theta degrees by 360 degrees. And a segment area equals sector area minus the triangle made by the chord and the radii. So, what do we learn from this? We learn how to find perimeters for simple shapes, how pi links circle length and size, how to find arc lengths and sector areas, and many area formulas, including Heron and Brahmagupta for tricky cases.
Let us quickly remember. Perimeter is length around. Area is space inside. Circle formulas use pi. Arcs use angle divided by 360 degrees. And heron uses the semi-perimeter S.
Keep practicing with small examples, draw pictures, and use these formulas step by step. You will get confident soon.
Happy learning! And if you want more practice problems and clear notes, explore similar lessons on EduRev for friendly help.